Hello, this is a video to demonstrate what I did for the second assignment in the Computer Systems and Networks module. My project is called stockHome, so it's a way of measuring the weight of items that you have in your house and sending them to a web app and sending email notifications via ThingSpeak and IFTTT. So just a way of keeping stock of items in your home or your business or whatever. I've made a scales as a very basic scale using a load cell and two planks of wood. So if you place an item on top of this scale, the load cell undergoes a small deformation, and that's measured by strain gauges on the side of the load cell, on the sides of the load cell. So when the metal load cell deforms slightly, the resistance of the strain gauges changes, and you can there's a measurable change in voltage that we can convert to. We can correlate with the change in weight on top of the scale. This is connected up to my Raspberry Pi, as you can see. So just to demonstrate some functionality here, I've got a 1 kilogram bag of pasta, and you can see here on the left that this is what the scale is measuring. Place the bag of pasta on, and it's overshot by 10 grams, but it's pretty accurate. This is a 250 gram sugar or coffee. 400 grams of pasta. The load cell communicates to the Raspberry Pi through this small commercially available PCB. It's called a HX711 load cell amplifier. So if you Google these, you can find these in electronic stores. It consists of a analog to digital converter and a signal amplifier. So the change in voltage that occurs in the load cell when the weight is placed on is very, very small. So it amplifies the signal, and then it will convert that signal from analog to digital. So this digital signal can be read quite easily by one of the GPIO pins on the Raspberry Pi. And this schematic, it also shows like the general way to hook up this load cell amplifier. So you've got the 5 volts GPIO pin voltage supply going into it here. And then you have another connection to a ground pin on the GPIO of the Raspberry Pi. And then the purple and yellow wires here, one of those is for collecting the bits of data from this PCB, and the other is to send a pulse back to the load cell amplifier. So every time a bit is received, the Raspberry Pi actually sends a pulse back to say that it has received that bit and it's time to send another one. So this is the load cell amplifier chip. This is one I actually fried by putting the voltage and ground pins on the wrong way around, quite stupidly. But I had a spare one, so that was okay. And there was just some light soldering required on this chip to just to get these this terminal and these pins put onto it. And the code that interfaces with this chip I imported from GitHub, and the link to that GitHub page is on the is on the description for this video, and we can go into that code to see how it works now. So this is the code that interfaces with the load cell chip. And I reiterate, this is not my code. This is the code taken from the GitHub page I have referenced earlier. So I'll just focus on the meat of this code, which basically underlines how it collects bits, packs them into bytes, and then converts that into a value. So we've got this function here, read next bit. Then these two lines of code are your pulse. It's pulsing. The Raspberry Pi will send an output from its GPIO pin. The true is the pulse being set to 1, and the false is the pulse being set to 0. And then it takes a value. The value is the GPIO input from the pin. This D out value will be set as the correct value for the pin that will take in input bits, and then it returns that value. So this next function, read next byte, is going to pack the bits read in the previous method into a byte. And in this for loop, it references the previous method, and it has some of these shiftwise operators that function sort of in a way where I'll demonstrate with this simple script here. So if I enter in some bits, we can see that each additional bit that is entered is shifted over to the rightmost side of the byte. So then there's another method here, read raw bytes, and this is referencing the previous method, read next byte, and it's doing it 3 times. So this load cell chip is going to take 3 bytes or 24 bits of data for each measurement. And because the voltage change that could be measured could be positive or negative, the binary data will come in a 2's complement value. So in this code here, the 3 bytes are joined into a single 24-bit 2's complement value. And there is a method called here to convert that 2's complement value into a standard binary value. And then finally, it returns the integer conversion of that binary data. So I have created my own code where I import the code that we just seen. So you can see in this line here, I'm from HX711 import HX711. So that's importing the file we were just looking at into this, which is my own code. So stockHome.py. So in this code, I'm just setting up a few things where I can send the data to different services where I can display them, I can analyze the data, etc. So here is some setup for the Firebase database. Here is a function which will set up information for the ThingSpeak database. And I use both Firebase and ThingSpeak to transfer information to my web app and to send email triggers to the user. So I call an instance of the HX711 method here. So I have pin 5 for the clock and pin 6 for the data. I set a reference unit which is 471, but this reference unit, it's applicable to it's a calibration number applicable to my scales. So when the first time you use the actual scale, you'll get quite a large number, and you have to put a known weight on the scale and then divide that measurement by a reference number to give you the correct reading. And once you've done that once, you've done it. You've done it for everything. So it's just a calibration number for your particular scale. And the hx.getWeight call here is basically just going to call the functions that we went through looking at on the previous file to collect bits, 24 bits, pack them into 3 bytes. They'll come in as 2's complement, and you convert them from 2's complement, and then it will convert it from after it's converted from 2's complement, the binary data is converted to an integer, which is printed out here. And this while loop keeps it going until it's stopped. So from there, we go into the Firebase real-time database, and we can see that the values that I'm measuring, and I've just picked a couple of different household items here: coffee, potatoes, and sugar. And I've just taken some weights previously, and they're seen recorded here in the Firebase real-time database. So this is what I'm using to transfer files or transfer data from my Raspberry Pi and to my web app. Also, we can see here in my ThinkSpeak channel for stockHome, we have some charts that I embed into the HTML of the web app. So this is the web app, and you can see I just have it laid out with like just the items I chose: potatoes, coffee, sugar, percentages of availability. So I picked like a max value that I wanted to keep stocked to, and when you take a measurement, it does some basic calculation in JavaScript to work out a percentage. It tells you the date that the measurement was made and the actual weight measurement in grams. And here are these graphs that I mentioned earlier embedded into the web app. So finally, I also use IFTTT to just create some email triggers. So you can see I've made 3 of them here, one for each item, and they react alongside the data when the data is sent to ThinkSpeak. So I'm using a Thing HTTP trigger and a React. So just for example, the potatoes I set for when the weight is less than 1,000 grams, just to test it. And as you can see here, I've been receiving plenty of webhook emails during my experimentation for running low on the items. So that's it really, and I'd like to thank you for taking the time to watch the video. I hope you found it interesting, and have a happy new year. Bye.